So let us look at another problem now in this lecture. Again, we are looking at arrangements of the alphabets in independence. So how many arrangements of independence are there with all vowels together, and secondly, all vowels never together? So the choices are 6,000, 2,000, 12,600, and 164,6400, 2,000, and 160,000, and the fourth one is 16800 and 164,6400. So the correct answer for this question is the fourth one. And let us look at the solution. So the first part was where we wanted all vowels to be together, right? And we have done such a question where we wanted all vowels to be together. The first task is to identify what the vowels are in independence, right? So we remember that I spoke about whenever you see this term together, that means that here all vowels are together, or in general, you have to consider some objects together. You consider the objects together, and you also consider the arrangements within those objects. So here in this case, what are the vowels? The vowels are I and E, right? So I is occurring just one time and E is occurring 4 times. So we have to, I'm just putting a rectangle around it. These are the vowels that need to stay together. And apart from that, we have N, D, P, N, D, N, C, right? So we have 12 objects and 5 of them are vowels, and remaining these are 7 objects. So what we have to do is we have to consider arrangements with I, E, 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 E as a single object multiplied by arrangements of I, E, 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 E. So we had covered such a problem before. So here, like before, I treat I, E, 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 E as a single object and then try to move it around in the arrangement with other letters, which are 7 objects, and also consider what internally can actually be possible for I, E, 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 like how many ways I can arrange this particular object internally, which consists of 5 vowels, right? So the first part, that is arrangement with I, E, E as single object. What is that equal to? If we look above, we have 7 objects and we consider this as one object, then we have 8 objects, right? 7 plus 1, and you have repetition of, you have 3, N repeated 3 times and D repeated 2 times. So what is the value for these arrangements? The arrangements, this is equal to 8 factorial divided by 3 factorial and 2 factorial, right? So this is how we do this here. And the second part, that is arrangements of I, E, 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 E In this case, how do we find it? You have 5 objects here, right? And how many objects are repeated? E is the one which is repeated, right? E is repeated 4 times. So what is the number of arrangements of I, E, 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 E? That is 5 factorial divided by 4 factorial, right? Because we have 5 objects and E is repeated 4 times. So you should be familiar with this formula so much that you should just write it down like this: 5 factorial, 5 objects, and E is repeated 4 times, so this comes in the denominator, and this is equal to 5. So the answer for part 2 will be a product of total arrangements we had to find with vowels together, that is equal to this number 5. And before we had found, what was the answer we found before? We found 8 factorial divided by 3 factorial into 2 factorial, right? So this was the product of these two numbers, 8 factorial divided by 3 factorial divided by 2 factorial, and using fundamental principles of counting, we had to take the product of these two numbers. And the answer to this is 16800. Okay. So let us look at the second part. Second part is, again, all vowels are not together. So we have done this many times. Arrangements of all vowels not being together is equal to total arrangements minus arrangements, or permutations you can call it, where vowels are always together. See, I'm just assuming that you will come up with this on your own now, because I have covered examples like this many times now. So the total arrangements we had found out before were, for this, I should write it down again so that you keep on pondering about it. Total arrangements in independence, that was 12 factorial divided by 4 factorial and 3 factorial, 2 factorial. This was a problem which we covered before, and this is part 1. And part 1, the answer was 16800, and if you subtract 16800 from here, you will get 1646400. This is the right answer.